Hi everyone, this is Mrs. Parr, and on this episode of Math Up to Par, we are going to be talking about numerical patterns, and that means patterns with numbers. So, numerical patterns follow a rule. All patterns follow a rule, but patterns with numbers follow rules that have to do with numbers. So, when you look at a pattern, you have to decide, are the numbers going up or are the numbers going down? Because if the numbers are increasing, and increasing means going up, then the pattern is either adding or multiplying. So if the numbers are increasing as the pattern goes on, then that means you are either adding something to the previous number to get the next number, or you are multiplying something to the previous number to get the next number. If the numbers are decreasing, and decreasing is the same thing as going down, so the numbers are decreasing and going down, then the pattern is either subtracting or dividing, okay? You will need to determine the rule before you are able to extend the pattern. So let's practice that. So let's look at these patterns right here. So this first pattern, I noticed that the numbers go from 3 to 7 to 11 to 15 to 19. So these numbers are going up. These numbers, it starts at 1, then it goes to 3, then 9, then 27, then 81. So these numbers are also going up. Looking at these numbers right here, 125 to 105 to 85 to 65 to 45, those numbers are going down or decreasing. Then here I have these numbers which are also decreasing or going down. So these patterns are increasing, these patterns are decreasing. So when they are increasing, I know that I'm either adding or multiplying, okay? I'm gonna try adding first to see if it works. If that doesn't work, then I'll try multiplying. So to go from 3 to 7, I count 3, 4, 5, 6, 7. So I would have to add 4 to my 3 to get to 7. After 7, let's see if I can add 4 to 7 to get 11. 7, 8, 9, 10, 11. I can. Let me check it one more time. 11, 12, 13, 14, 15. It appears like each time I take the previous number and I add 4 to it, I get the next number in the pattern. So that means that my pattern is probably adding, okay? So my rule for this pattern is add 4. Looking at this pattern right here, I go from 1 to 3. So let me try adding first to see if that works. So 1, 2, 3. So 1 plus 2 equals 3. So let me see, if the rule is add 2, I should be able to do that to the next number. So 3 plus 2, 3, 4, 5. Well, that doesn't equal 9. And if I add 2 to 9, that's definitely not going to equal 27. So that means I can't seem to find a rule with adding, but this pattern is increasing. But I also know that it could be multiplication. So I'm going to take this number and I'm going to go back and I'm going to try to multiply. So 1, I know that 1 times 3 equals 3. So let me see if I can multiply each number by 3 to get the next number in the sequence of the pattern. So then I have 3 times 3. 3 times 3 is 9. Then I have 9 times 3 is 27. And if I work out 27 times 3 over here to the side, I'm going to check my work. 3 times 7 is 21. Carry my 2. 3 times 2 is 6. Plus 2 is 8. So yes, in fact, 27 times 3 is 81. So that means that this is a multiplication rule. And specifically, it follows the rule of multiply by 3. Okay? So now these patterns right here are going down. Okay? So just like when I did adding and multiplying, I'm going to try subtracting first. I'm going to see if the subtracting works, and if not, I'll try division. So in order to figure out my subtraction, I'm going to take 125 and I'm going to subtract it. I'm going to subtract 105 from it. So I'm going to take 125 minus 105. Okay, So 5 minus 5 is 0, 2 minus 0 is, oh, yep, and 2 minus 0 is 2, and 1 minus 1 is 0. So that means there's a difference of 20. So that means if I say 125 minus 20, I, in fact, get the next number in the sequence, which is 105. So let's see if I take 105 and I subtract 20 from it, if I will get my next number in my sequence. So 5 minus 0 is 5. I can't do 0 minus 2, so I cross out my 1, make it a 0, make this a 10. Oops. And I have 10 minus 2 is 8. It looks like 85 is my next number in the sequence. So now I'm going to take 85 and I'm going to subtract 20 again to make sure. 5 minus 0 is 5. 8 minus 2 is 6. And in fact, that is. So it appears that the rule to this pattern is a subtraction rule. And each time I'm subtracting 20. So subtract 20 is my rule. Go ahead and erase this work so I have space. All right, so my final pattern, I start with the number 32. So just like I did with subtraction, I'm going to subtract these numbers from each other. And I'm going to see, all right, what's 32 minus 16? 2 minus 6, I can't do, so I cross out my 3. I make it a 2. I make this a 12. 12 minus 6 is 6. And 2 minus 1 is 1. So that means that I subtract 32 minus 16 to get my next one. Well, if I go ahead and I do 16 minus 16, I'm going to get 0. I'm not going to get 8. So I'm noticing that subtraction is not going to work for this pattern. So if subtraction doesn't work, then I'm going to go ahead and I'm going to try division. Okay, so I need to figure out 32 divided by what equals 16? Well, that problem might be a little tricky for you, especially if you're trying to do it by hand. But any part of the pattern follows the rule. So with the other patterns, I started in the beginning, but you might be more comfortable starting with one of these numbers right here, because I can tell you that 8 divided by 2 would equal 4. And I know that 4 divided by 2 equals 2. So if I'm noticing a divide by 2 pattern over here, then it's probably true over here. So let's check that. If I take 32 and I split 32 in half, so whether you do that by doing long division, using either the traditional method, the box method, hangman, whatever method you use, I'll show you traditional. 2 goes into 3 one time. 1 times 2 is 2. 3 times 2 is 1. I bring down my 2. 2 goes into 12 6 times. 6 times 2 is 12 with a remainder of 0. So 32 divided by 2 is 16. And if I take 16 divided by 2, I get 8. And if I do 8 divided by 2, I get 4. Okay? You can check this by going the opposite way, and the opposite of division is multiplication. So I know that 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32, which means going the opposite way, it's dividing by that number. So this pattern is a division pattern, and specifically the rule is divide by 2. So I want you to look at the difference. With my adding and my multiplying pattern, they were both going up, but when I look from the start to the finish of this pattern, it definitely increases, but it doesn't seem to increase by a lot very quickly. However, in this pattern, it starts at 1 and it ends at 81. So in only 5 numbers, it's jumping up quickly. It doesn't seem like as big of a jump from here to here or from here to here, but then they start looking like much bigger jumps. So when you notice that, that is a good clue that it's a multiplying pattern. You'll notice the same thing with subtraction and division. With subtraction, this is a big number right here, but it seems to be going down pretty steadily, okay? It's a steady decrease, whereas this one goes from 32 all the way down to 1 really quickly. And so it seems to be that these jumps are bigger than these ones down here. So you'll notice adding and subtracting patterns are more steady. Okay, you're going to notice a steady increase over time. Whether it's a decrease or an increase, you're going to notice it's going to kind of follow the same pace. But for multiplying and dividing, you're going to notice parts of your pattern that are closer together and then parts of your problem that jump really far apart. Okay, so all of those clues can help you with figuring out the rule of the pattern. And once you know the rule, you can then apply that rule to that number and extend it further and continue on after that. All right, guys, thanks so much for listening and happy practicing. Bye.